Okay, so let us now start the second part. So you see that this theorem is not very useful if you somehow know some integrals so that you already know if they are convergent or divergent and be able to compare your integrand with the integrand of those functions which you already know about them. There are two theorems here which is expressed in one theorem in your book. These are called P integrals of type 1 and type 2. I am calling them type 1 and type 2. It is in the one single theorem in your book. But this integral is a type 1 P integral. So I want to talk about P integral of type 1. So if you have integral from a to infinity, if a is positive, 1 over x to power p dx, this is called a P integral of the first type. So it is improper of the first type. Yes, because I don't have any problems here, because I'm assuming myself that a is positive, so the only problematic point is carved out, is singled out. So I am going from a positive number to infinity. So it is definitely not of second type improper integral, it's the first type. And there is a theorem for this one. Either you have to have it in your memory or learn to derive it, because the derivation is very simple. So I have it in my memory, at least for this one, if I do it correctly. So if p is less than or equal to 1, this integral diverges to infinity. Okay? And if p is strictly greater than 1, then this integral converges, and I know the value is x to power p minus 1, a to power 1 minus p. Let me cheat a little bit. So I'm not... That's correct. Yes. So this is what you need to know, or you should be able to derive it, okay? But I just want you to know that P integrals of the first type and the second type are famous ones. We already know if they are divergent or convergent.
What does P integral mean?
P integral means just this integral. This integral is called a P integral. Yes? An integral of 1 over x to power p. For example, if I say 3 integral, 3 dash integral, it means 1 over x to power 3. Yes? So, for example, let me just derive this one for you. Let us consider that p is 1 first. If p is 1, what happens? And I want to be a little bit sloppy because I want to accelerate a little bit. So, this becomes from a to infinity 1 over x to power 1 dx. Okay? So, I know that I have to take the limit. R goes to infinity and integral from a to r 1 over x dx. But do you see that this becomes infinity? Do you agree? Because this becomes ln of x, so it becomes ln of absolute value of r minus ln of a. I don't consider absolute value because a is positive. And then I send r to infinity. So do you see that this becomes infinity? So if p is equal to 1, the p integral diverges to infinity. So what happens if p is less than 1? If p is less than 1, what happens? Then my integral will be integral from a to infinity 1 over x to power p dx. So this becomes the limit of integral from a to r. R goes to infinity. But I want to do this integral. Do you remember? I bring it up, so it becomes x to power minus p dx. And I calculate this integral, very simple one. So this becomes the limit, r goes to infinity. This becomes x to power minus p plus 1 divided by minus p plus 1. But I have to run it from a to r. Do you agree? So that is why it is good to remember this, how to derive it, because if you forget it or if you get confused with the other one, which is very similar to this one, you should be able to derive it yourself. Okay? For any case, of course you don't need the most general case, you can consider it case by case. But let us understand that. In order to calculate this, I have to replace x with r and infinity, r and a, so it becomes limit r goes to infinity. I replace x with r, so it becomes r to power, instead of minus p plus 1, let me write 1 minus p, and then this also 1 minus p, and then minus, this becomes a to power 1 minus p and 1 minus p. Yes? Okay, this one is a fixed number. It does not depend on r, so it remains the same. But I am sending r to infinity, and I am assuming p is 1, less than 1. So can you tell me what happens? If p is less than 1, 1 minus p is positive. So it is r to some positive power. And I am sending r to infinity. What happens? This part becomes infinity, and this is a fixed number. Infinity minus a fixed number is infinity. So you see that for p equals to 1, it is infinity, but the argument goes along this line. But for p strictly less than 1, still the answer is infinity, but the argument should go along these lines. But if p is greater than 1, let me just tell you, so you can yourself find it yourself, you know. If p is greater than 1, everything remains intact up to this point, but the limit will change. Can you tell me what will be the limit? So everything, so let me, if this is the case, dot, 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 I will come up to here. Okay, can you tell me what the limit is now? If p is greater than 1, what happens to 1 minus p? It becomes negative. R to a negative power, it means that I can take it down to make it r to a positive power. But r goes to infinity. So this means the limit of the first part vanishes, and this is left for me. And this becomes a to power 1 minus p, and I use this minus sign to flip them, so it becomes p minus 1. So if p is greater than 1, this integral converges, and I already know the value to which this integral converges. That's this one. Okay? So let us see how this theorem is useful. I think, let me solve one of the workshop problems. That's a good problem. So let me write this one. It is the first one in the module question. Integral, for example, x squared. Let me first give a simple example. So what do you think about this integral? So for example, from 2 to infinity of 1 over x to power 5 dx. What do you think about this integral? Does this converge or diverge? Converges. Why? Can you see this is a p integral of the first type? It is comparable to this one. A is 2 in my problem, and p is 5. So p is greater than 1. So this means definitely this integral converges. And even if you want, you can say to which value it converges. It converges to what? It converges to, instead of a, you put 2. Instead of p, you put 5. Yes? Whatever that number is. So it is 1 over 60. Yes? Now my question for you. Let me make it a little bit simpler. So I give you this integral. What do you say? I don't know, 10. What is this integral? This is not a p integral, yes? Because I have an extra 10 in the denominator. And I am not asking you this time to find its value. I am asking your opinion about if this converges or diverges. Okay? So you can compare it with one of those integrals that are famous, and you have it in your memory. Yes? So how can I say?
It's less than that one.
Less than that one. So you say that 1 over x to power 5 plus 10 is greater than equal to 0, of course, on this interval. And it is definitely less than 1 over x to power 5. But 1 over x to power 5 is famous for me because I know this theorem, and I know that this is a p integral which p is greater than 1. So I know the bigger one, the integral of the bigger one converges. According to the theorem we just had, this also converges. I am just telling these orally so that we save some time. You can see the video, but you have to write it down. But now let me also ask you your opinion about a little bit nasty integral. So x to power 5 but minus 10. What is your feeling? Because you know that when x is extremely large, it doesn't matter you are adding 10 to it, we are subtracting 10 to it, from it, yes? So it means that if this integral is convergent, your feeling is telling you that this also should converge. But I want you to see that the analysis of this one is not as simple as the previous one. Because, can I say this one, which one is correct? Is this one correct, or this one is correct? The second one is correct, but the second one is useless. Because what type of integral is this? It's a p integral p greater than 1, so it is convergent. I know this function is bigger than my function. So even though this is converging, it doesn't say anything about this. So do you understand the subtlety? So you have to know, so this is, first of all, this one was the ideal scenario, but unfortunately the ideal scenario was wrong. The correct scenario is this one, and it is useless if I want to use my theorem. So how can I solve the problem? Yes?
Can we do 1 over x to the 4 instead? And then say 1 over x to the 4 is greater at some point?
Yes, probably you can do that. That's a good idea. But I think for constants, my advice for you is to do it like this. So if I have x to power 5 minus 10, instead of this fixed 10, I want to write some expression in terms of x5, which is definitely guaranteed. For example, can I write this one? I don't know, I am not saying that this is my way is the best way. You can still do your own way and you can defend it. But do you agree with this one? Yes? Do you agree with this one? Because if I want to make it true, I have to claim that this one is bigger than that one. So I have to convince you that x to power 10 minus 10 is greater than x to power 5 minus 1 over 2x5. Yes, this is 5. I have to convince you about that. Yes, and this means that these are gone, so I have to convince you that 10 is less than or equal to 1 x to power 5, so it means that I have to convince you that x5 is greater than 20. And it is the case because I start from 2 and x to power 5 goes beyond 32. So this is definitely true. So what you said is correct if you can defend yourself, very good. And this one is also one technique. You can replace numbers with some functions of x so that you can simplify to a p integral and get rid of that one number.
Choose the function.
Yes? Understandable? This is one way. I'm not saying this is the best way, but that's a good way. So if this is given, you say that I claim that this one is smaller than that one, and you go around these lines and prove it. And now what can I write here? This becomes 1 over 2 x to power 5. And then 2 goes up, it becomes 2 x to power 5. Be careful, I am not comparing it with 1 over x5 because 2 is still there. I am saying that 1 over x5 converges, so 2 times that one will also converge. That is the logic. Okay. Now let us go to this module question. Integral from 2 to infinity, x squared plus 1 plus square root of x, and then divided by x square root of x plus x squared dx. Okay? So you want to see, and I just want to tell you one strategy how to tackle these problems because they are complicated. Even if they make it complicated, I have to do a lot of trials and error. But at least I want to give you a strategy how to go forward. This is integral, improper integral of type 1. This is my advice for you. What is the degree? Of course, I cannot talk about the degree of the numerator because I have a square root, but what is the nominal degree of the numerator? The highest power. This is x2, this is x to power 0, this is x to power 1/2, so the highest one is 2. What is the highest degree in the denominator? This is x times x to power 1/2, so it is x to power 3/2, and this is x to power 2, so the highest one is 2. So, then if you reduce this 2 from that 2, what is left for you is 0. The degree of the denominator minus the degree of the numerator. So degree of denominator, so let me put it in quotation mark, in the denominator minus the degree of the numerator. Okay, so this becomes 2 minus 2 is 0. This is your P. P is 0, is less than 1, so it is what? It is convergent. Sorry, it is divergent. It should be divergent. Okay? But this is just a hand-waving argument. But it will tell you how to move forward. So by this analysis that I told you, I get a feeling about if my integral converges or diverges, because it really matters. If I want to prove this is going to diverge, I have to start using these kinds of inequalities. But if I want to prove that this converges, I have to change my strategy from the very beginning. So this will give you an intuition in which direction to go. By this hand-wavy argument, you realize that because P is 0 and this is divergent, I will not use making the integrand smaller than something. I will try to make it bigger than something. And that is extremely important from the beginning. Okay? So now can you tell me how can I make it bigger than something? You don't need to do it in the best optimal way. You just do it, but make sure it is correct. And the other piece of advice is to keep the highest power and the highest power in the numerator and denominator. For example, can I just ignore these and write this? I just want to tell you, don't try to do it in an optimal way. There's no optimal way here, but make sure that you are doing what is correct. So do you realize that I am making it bigger, and it was very crucial? Because if I don't know my strategy, is it going to be divergent or convergent, I am in limbo situation. Sometimes I think about doing it in that way, and then, oh, it doesn't work, so let me do it the other way. So it is better to have an idea what you are doing and then go for it. Okay, so I know that my goal is to make it divergent because of this hand-wavy analysis. So I will not go for a smaller than, I will go for greater than. Okay, and then do you agree this one is true? Yeah. Why? Because I kept the denominator the same. I throw this out, and then I am working on this interval, so x is positive. So that's correct. But before continuing, if you can simplify. Can I simplify something here? For example, I can divide everything by x. So this becomes x divided by square root of x plus x. I divided everything by x. Okay, but that's not enough yet, because this one, in case you can calculate this integral and you are lucky and it becomes divergent, you are done, because this one will also be divergent. But if not, let us continue. So in the numerator I have one expression, I keep it. Which one has the bigger power here? X. Let us keep, if possible, let us keep x somehow. What can I do? Can you tell me? Just x. Do you agree? I can write x plus x. Yes?
Can you explain that more?
You see, this x I copied and pasted. There's nothing I can do in the numerator. There's only one term. But between these two, which one has the highest power? X. If possible, I want to keep this one. So I want to sacrifice this one in favor of that one. So the first thing comes to mind is to replace this one with that one. But you have to make sure that this inequality is the right inequality. And that is right. Why? Because which one? If you compare this one with this one, I hope that you agree that this one is smaller than that one. So this means the whole fraction is bigger than this one. And this is enough. Why? Because now this becomes x divided by 2x, and it becomes 1 over 2. And this is a zero integral. So our hand-wavy argument was correct, because we guessed that p should be 0. So this is 1 over 2. Okay? Now, if I integrate, or you can say that the integral of this function, because my function is always greater than 1/2, and now I do it from 2 to infinity. Do you see that this is divergent? Because this becomes 1 over 2x. I have to do it from 2 to r, and then send r to infinity. I'm a little bit sloppy. I hope that you agree it becomes infinity. But I want you to understand, if you just want to do the calculations randomly, it is extremely hard. Because you do some calculations to make it bigger, it doesn't work, and then okay, let us change the strategy, it doesn't work, then you don't know what you are looking for. But if you do this hand-wavy argument, then you already know what to do. Okay, and then there are some videos, I am solving a lot of these questions, and I have put it on this. This is a refresher course, so I was concentrated mainly on the solving exam problems. So please go and read watch those videos, but before doing that, please try to do them yourself, okay? Any questions? Okay, so let me also go for another one. There is another P integral of type 2, okay? And that is this one. Okay, so P integral of type 2 is this integral. Integral from 0 to some number a is positive, 1 over x to power p dx. This is an improper integral of the second type. Because a is a number, so my interval is not unbounded, but I have problem at 0. Okay? So then it is hard for me to remember this one. So I know that this should be the other way around. So it means that if p is greater than 1, this I know is infinity. You can convince yourself about. So you have to write it from C to A and send C to 0 from above. And then this will be, I think, the other way around. So it will be a to power p minus 1 divided by p minus 1 if p is less than or equal to 1. I suppose this is correct. Is that
1
right?
minus p.
What?
1 minus p.
Oh, 1 minus p. 1 minus p. So it shouldn't be correct. So p equal to 1 is this here. Yes, now it's correct. So 1 minus p for both. But that is not important. You know that this is another integral that you have. So exactly around these lines, I really advise you go home and do it. Because if you cannot remember it, then you have to derive it yourself. Okay? But of course, in that case, you can derive it case by case. So let me solve one example of this type. For example, let us solve this example 21, part 2. Okay? So I have integral from 0, is it to infinity? Yeah. Yes, so it is to infinity, and I have dx divided by the second root of x cubed plus x. Is that right? No, x plus x cubed. And the question is that, is this integral, you see, determine whether the following integrals converge. Okay. So what is your opinion? First of all, this is a mixed improper integral. Why? Because first of all, you see infinity, so it is type 1. And you also see that you have a trouble here, because if I put 0 here, the function is blowing up, it's not defined. So it's a mixture. You remember what I said about mixture integrals? You have to break them so that you consider, so you have one problem at a time. So it means that instead of this integral, you consider two integrals, so that one of them is only type 2, one of them is only type 1. Okay? So what do you guess? What is your breaking point? Because you go from 0 to infinity.
1.
Yeah, 1 is good. So let us choose that. So 0 to 1, and then I have dx x plus x cubed, and the other one I go from 1 to infinity, dx, then x plus x cubed. And then there is a theorem, it is not sensitive to what number you choose. But now let us see that this breaking is good, because the second one is only type 1 improper. The first one is only type 2 improper. Okay, that's at least good. Okay, let us start from here. If I am lucky and this integral diverges, I don't even bother about the other one, because we can say that this integral diverges. If this converges, then I have to do the other one as well. Okay? But now let us try to do this one first, because now you have experience of the p integrals of type 1. The hand wavy things, what is your feeling about this integral? by that hand-wavy argument that I mentioned. So let us write it here, integral from 1 to infinity dx divided by x plus x cubed under square root sign. Yes?
Should the highest in the denominator be 3 by 2?
Yes.
And then the highest in the numerator is just 0.
0. And then you subtract the highest in the denominator from the highest in the numerator, it remains 3 halves. And 3 halves is this one. Yes, so we think that this integral should converge. Okay? So that is the argument. So this is, you don't, because this is the second root, the highest power is 3. And then what do I have? This is the 1 over 2. So it is 3 over half. So the degree of the denominator is 3 over half, the degree of the numerator is 0. So the denominator minus the numerator remains 3 halves, and 3 halves is greater than 1. So I believe that this should be convergent. So it actually helps me to find my strategy. So my strategy will be to do less than or greater than. Which one is suitable for this case? Because I realize that I want to go for convergence. So which one is useful to go? The first one. I want to make it small. So let us do that. So you start with your function. And of course this function is positive. So what can I write? I know that I have to go for this one. And I told you try to keep the highest power. So is it possible to keep the highest power? What do you say?
1 over.
Yeah, I can just simply drop this x, yes? Do you agree? Do you agree with this one? Because x is greater than 1, so this is definitely smaller than that one. And why I'm done? Because this is just 1 over x to power 3 over 2. This is a p integral. A p integral, this one. So this converges by p integral that I wrote up there. At least if you don't remember these correct form, remember that this type of p integral converges if p is greater than 1 and diverges if it is less than or equal to 1. Now here this definitely converges, so this means that this smaller one also converges. So this one converges. So we go back here. Yes? But let us now understand this one. Here the analysis should be a little bit different. So you also have to get a feeling in which direction you are supposed to go. Yes?
If we know that it's already 3 over 2, why do we need to check for convergence?
No, we don't know that. That is hand-wavy argument.
Oh, so it's not guaranteed.
No, it's more or less guaranteed, this idea. But if you want to do that, you have to prove a separate theorem for yourself. And that is very hard because I am considering all possibilities. I cannot even talk about the degree. Because degree only works for polynomials. Yes? So this is a hand-wavy argument which always, by my experience, give you the right direction.
Okay, so it tells us the answer, but we need to find the difference.
Yes. You need to find a precise argument to reach to that answer.
Okay.
But it is very important here, because if you don't know the answer, you don't even know in which direction you want to go. Are you going for divergence or are you going for convergence? And it matters. Yes, that's the only guide for you. Okay, so now, in this case, what do you think will happen? I hope that you see that this new p integral is useful here, because this is of type 2. So I have to use type 2 p integral. But in this case, this is the other way around. If p is less than 1, converges. If this is greater than or equal to 1, diverges. But here, the argument would be a little bit the other way around. In the case that I go to infinity, I will try to keep the higher power. Because if x goes to infinity, higher powers of infinity are bigger than the lower powers of infinity. Yes? But here, my problem happens around 0. A number close to 0. If a number is close to 0, which one of these will dominate?
X.
X will dominate, not x cubed, because x cubed is smaller than x. So this means that if I want to understand nominally the degree, I wouldn't say 3 over 2. I would say 1 over 2, because this is the dominant term. Okay? And 1 over 2 is the new situation. 1 over 2 is less than 1. So it converges again. So it already tells me what to do. Okay? So again, I go for convergence, but this time I will keep the lower degree ones, because that will dominate around 0. Yes? So can you help me? Can you help me? Do you understand what's going on? This is different from the case of infinity. In the case of infinity, I go for the higher degrees, because that is the dominant term. But around 0, I will go for the lower ones, because that's the dominant. So this is comparable to x. So I have to get rid of this. But I hope that you can say what I should do. What can I write? Just square root of x. Do you agree, first of all, this is correct? And then this one is 1 over x to power 1/2. So this is a p integral of type 2. Why type 2? Because I have problems at 0. And then it is on the board. If p is less than 1, it converges. So this converges. This implies that this one also converges. Now this integral converges based on this analysis. This integral converges based on this analysis. So my original integral also converges. Yes? And of course you can make an estimate. Yes? You can calculate this integral. It gives you an upper bound for the first one. And you can calculate the previous one. And it gives you an upper bound for the first one. So this means that if you add these two, it gives you an upper bound for the original. But this is not wanted in this question. Yes, please.
Why can't we use what we learned yesterday?
What is that?
C. We put in place of 0 C. And we
Here?
and we take the limit.
No, because we
No,
cannot.
there.
Here?
Yeah, to calculate.
Yes, you can do that.
Okay.
Because that's why I'm telling you, to learn these things, so that if in the exam you forget about the formulas. But one thing I want you to remember is the conditions. If you remember the conditions, then you know in which direction to go.
No, I mean the type we used yesterday.
Yes, you can do that for this part.
Okay.
Yes, you can do that. But at least you need to know that you are comparing it with a p integral and your problem is solved. Because it is even better to do it in the exam. I don't know if you just say that because of those theorems in the exam. In the book they will accept it from you. But of course you are right. If you don't do that, do this as we learned yesterday and definitely you get a number. Yes? The only reason that I didn't want you to do that, because here you really don't need that number. In the previous exercises we wanted that number. You just want to convince ourselves it is convergent or divergent. That's it. That is what you decide. So, any questions? So let us stop this one lesson. That's enough. And then, but we have to do a lot of practice. And I told you already, there are some videos that I have put for you there, so you can just go. And many of these questions in blue from module or exam questions, I have solved them there for you. Okay, but now let us go to the next part of the lesson. Is using integrals to calculate areas and volumes. So. And by the way, I did this with Gemini. It is artistic, isn't it? But sometimes it becomes very dummy. It doesn't understand that, okay, this C is wrong. I will fix it later for you. So, yes, and then there are beautiful pictures, you know. You can generate them by Gemini. Of course, yeah, I did it with GeoGebra precisely, and then copy and paste it and put it in Gemini and said that, okay, make it artistic, okay, somehow. So, this is very good. I mean, we have to learn how to use these tools. Okay, but let me try to give you an idea about this lesson. I think about the areas you already know quite a lot. And of course, even for the volumes, you know a lot. Have you learned them in your high school studies before? Yeah. So if you have done that, of course, I have also a lot of videos for high school, so if you need to go in a lower pace, you can watch them. But here, let me tell you some ideas that we need to do. So the first thing about area, the area. So this is the standard one. If I have a non-negative continuous function, which is always above the x-axis, and this is area, and this function is f. So how can I calculate the area?
Integral.
Area is the integral of f of x dx from a to b. Okay? And if this is below the x-axis, always below the x-axis on the interval of interest, this area is not in the integral. Do you know why? Because the integral is the Riemann sum, and this function is always negative, so all the Riemann sums are negative. So if you take the limit, and if you're lucky the limit exists, the limit should be a negative number, which is not correct to say this is the area. But can you tell me why the area becomes suddenly negative of that number? Yes? Can you tell me? And it is important to remember, if the area, every part of the area is below the x-axis, I am claiming you that this area is negative of your integral. Why is that?
Because it's absolute value of the integral, so when it's bigger than, it's just x, but when it's less...
But there's no absolute value here.
Well, you need to put the absolute value, right? But then when you
No, we cannot just put something there. We have to defend that. Now, what I'm saying is that if this function is f, so imagine, so let us say that I make the mirror image of this function with respect to the x-axis. So what happens? I get this one. If this area from number point of view is A, do you agree I can call this A still? If that is the mirror image. But this function is f, this function will be a different function. I can call it g. But if I want to write it somehow which is related to f, we can give it a name. I can call it g, but then you don't see any connection between this new function and the old function. Instead of calling it g, what do you think I would call it? Negative f. And now negative f is of this type. So if I want to find this area, the area according to this type becomes integral from a to b, but negative f of x dx. But then we learn that if the negative is under the integral sign, I can flip it out. Yes? So this means that if the area is below, you just do it with negative integral. And then I can have a mixture. So if I have a mixture, that's also somehow students get confused. For example, if I have this scenario, and here is A, and here is B, and let us actually hatch these parts. So these areas in total, so let me call this one A1, and this one A2, and this one A3. So the total area is what? Is of course A1 plus A2 plus A3, because I am interested in the total area. So if I find the area of each one of these parts individually and add them up, I will get my total area. But if I want to write it as an integral, be careful. So let me show you this point is, for example, C. That is why Gemini was confused here, I don't know why. So C and D. A1 is the integral from A to C, f of x dx, if this function is f. Do you agree? Okay, but plus, I still would put a plus, because I have a plus here. But A2, because A2 is below the x-axis, if I want to write it as an integral, I have to write minus the integral of my function, and it goes from C to D. Yes? And then plus again, this is plus again, integral from D to B, because now A3 is again above. So it becomes from D to B, f of x dx. But instead of writing plus minus, I just write minus. So be careful. For finding the total area, I am always adding the areas individually. But when I want to express it in terms of integrals, the ones that are above come with positive sign, and the ones that are below come with a negative. That's important to understand. Don't get confused here. Okay. So, might be it's better to do some area example. And then, okay, there is one more thing that I want to mention, is that what happens if I have two functions involved? For example, if I have this function and I have another function below it between A and B, and now I want, this is the function f, this is the function g, and I want to find this area. So how should I find this area?
f minus g.
Yes, you can do it. You can see that this area that I want is the integral of f of x dx from a to b which will be this area. Do you agree? Minus integral from a to b g of x dx, which will be this area. Okay, if I want to have my area, I have to subtract these two, so that becomes exactly the area that I want. This is correct, but because you know that I can combine them into one integral, you can combine them into one integral. So that's also acceptable if you want to use this directly. So if you want to find the area between two functions, you do the same thing, but the function which is above should come first, and the function which is below should come next. Okay? If you do it the other way around, you will get a negative value for the area, which will be meaningless. So it is important to know which function lies on the other function within the interval that you're working with. Yes, please.
What happens when one of the functions, let's say the one below, a part of that function...
It doesn't matter for this formula. So,
Okay.
so if you do it the other way around, this will be the same. Can you see why? This is a good question. So I think you are asking this question, aren't you? Something like that. So one function, so one part of the area is above, one part of the area is below. Was that your question?
Yeah.
Okay, so this is f, this is g. I am claiming in this case you shouldn't be worried, the formula remains the same. Yes? But the only thing that is important is that write the function above minus the function below. Why is that? For example, you can shift this, okay, by adding a same constant to this one and that one. But the area in this shift does not change. So what happens? This becomes f of x plus a shift c. This will be g of x plus the same shift c, and then shifts are cancelled. So it doesn't matter. So you shouldn't be worried about if you are using this formula. In this case, you have to be a little bit worried if it is above or below. But in this case, it doesn't matter. Yes? Okay, so let me solve one problem, and then probably if we have to finish everything tomorrow. It's not that much left, but so might be it's a good idea go to volumes, yes? Okay, might be you are a little bit tired. Let us just do one example for areas. So this example 6.2, that's a good example. Yes, let us do that. Determine the exact area of the region enclosed by the straight line y equals to x and the curves y equals to minus the square root of x plus 12 and y equals to the square root of x plus 12. Okay, so we want to solve that one. So it is a good idea to sketch a graph or a picture so that you understand what you are doing. So is the question clear? I want to find the exact value of the region which is enclosed by the straight line y equals to x. This is y equals to x. And those curves, one curve is the square root of x plus 12 and the other curve is minus the square root of x plus 12. Okay? So, do you have any idea how the graph of a square root of x plus 12 looks like?
Square root of x but shifted 12.
Yes, a square root of x, hopefully you remember something like this. This is the square root of x. But this is plus 12, so it is shifted 12 units to the left. So it will be something like this. Yes, if this is minus 12. This is the square root of y equals to the square root of x plus 12. If you can guess this one, then guessing this one is easy. This is just negative of that one. So it will be the mirror image of this one with respect to the x-axis. So it will be like this. Completely symmetric. Y equals to minus the square root of x plus 12. Yes? And now which area we are supposed to find? Enclosed by these curves and that straight line. So hopefully you agree with me, they are talking about this region. Yes? You want to find the exact value of this region. Okay. I want to mention something. So here you see that more than one curve is involved. So might be this is a better formula which calculates the area between two functions. But be careful here. My functions change when I move forward. Because from here, from minus 12, by the way, what is this point? This is up to us to decide. Because we need to decide. How we decide about that?
Equate them.
We equate them. So this, I want to find this point, so I equate these two. So square root of x plus 12 is equal to x. I square it and move it to the other side. So let me move this to the other side. Is equal to 0. And then I factorize it or use PQ formula any way you like. So I need two numbers with sum minus 1 and the product minus 12. Yes? And then if I put it equal to 0, either x is 4 or x is minus 3. But of course minus 3 is not acceptable here. It's not even the solution. So x becomes 4. So that is up to us to decide this point. And we did. That is 4. Yes? So this point is minus 12. So I go from minus 12 to 4. Okay? But the point is that when I am from minus 12 up to this point, this area is enclosed between two functions. One function is this function, the other function is this function. These two functions. But when I pass from here and go forward, again I am still between two functions, but one function is still the same, but the function below changes to y equals to x. Is that right? Yes? This is not the optimal way of doing it, but I want you to understand. You yourself have to understand to break this area, this region into two regions. Why? Because I cannot write the function above minus the function below. The function above is always the same. The upper boundary is always the same curve, but the lower boundary sometimes is this function and sometimes is another function. So this motivates me to break my region into two distinct regions and calculate each area and add them up. Okay? So if I consider this area number 1 and this one area number 2, can you help me to write area number 1? So the total area is what? Is the integral from this point to that point. Unfortunately, we also have to calculate this point as well. So what I have to do, I have to equate these two functions. So
Won't it just be negative 3 because we solved it and it's squared?
yes, it is negative 3. Yes, I agree with you. So if you agree with this one, so that's negative 3. Yes? Okay, and then what should I write? I have to write from negative 12 to negative 3. What should I write as my integrand? The function above is this function minus the function below is this function. So minus minus. Yes? This is for A1. But plus A2. What is A2? From minus 3 to 4. The function above is still the same. Minus the function below is x. Yes? And then I want to stop. You can calculate these integrals hopefully. But I want to change my strategy. This is correct, but it is very time consuming. Sometimes we do not have any alternative, so that we have to live with it. This is what it is. But sometimes we have a different alternative, and that is change my perspective. Instead of working with functions of x, I will start working with functions of y. Because if I look from this direction, I have the same boundaries. This will be always my lower boundary, and this will be always my upper boundary. So instead of calculating in this hard way, I can do it in a simple way. Okay, so this means that I can calculate this. Can you help me to do that? So if I want to see it from the other perspective, what should I do? I need to have the upper function written in terms of y, which is y, x equals to y, minus the lower function. It doesn't matter because I want to find x, I have to square it. When I square it, this becomes y squared equals to x plus 12. This also gives me the same thing. So from that perspective, that is just one single function. And then what is the answer? The answer is y squared minus 12. Yes? So y squared minus 12. And then of course I have to write dy instead of dx. But I have to find my y limits. The lowest y limit is here. The highest y limit is here. So what is the lowest y limit? We already found that this is minus 3.
Square root.
So it is also minus 3. Yes? Because it is on this line. If x is minus 3, y is also minus 3. So it goes from minus 3. What is the highest point? X is 4 and y should also be 4. Yes? So you see that this is much simpler to calculate. It is not even comparable to this one because that's just a very simple polynomial and I only need to calculate one. But here if I do it, it is correct, but I have to spend a lot of time to calculate it. So sometimes changing the perspective might actually help you to solve your problem simpler. Any questions here? Okay, so there are things that are left, so we will continue. So volume and parameterization and finding the length of the curve. These are not that much, but it always takes time. Yes? Any questions? Thank you very much.
Thank you.